Measurements. Length. Length is the distance between any 2 points. The SI units for measuring length is meter. There are, however, other units used to measure length. The table below shows the conversion of length into various subunits of meter. Perimeter of plane figures. The perimeter of plane figures is the distance around the boundary of the figure. For example, the perimeter of a rectangle with length L and width B is 2L plus 2B. Perimeter of a circle. For a circle with radius R, the perimeter is given by P is equal to 2 pi R, where pi is 22/7 or 3.142. Remember that R is half the diameter D of the circle. The perimeter can be calculated as pi D. In a circle, the perimeter is commonly called circumference, often represented by C. Example, for a circle with radius 7 centimeters, the circumference C is equal to 2 times 22/7 times 7, which is 44 centimeters, or circumference is equal to pi D, which is 22/7 times 14, which again gives us 44.
If the circle is a fraction, we remember to multiply the formula 2 pi r by the fraction of the circle. If it's half a circle, we shall have a half times 2 pi r, or simply a half pi d. So for a semicircle ABC with radius 28 centimeters, we shall have a half times 2 times 22/7 times 28. We multiply that and we get 88 centimeters. We remember this is the length of the curved line. Now we add the length of the straight edge, which is the diameter, that is 56 centimeters. So we have 88 plus 56, and that gives us 144 centimeters. For a quarter circle of radius 28, we shall have a quarter times 2 times 22/7 times 28, and that gives us 44 centimeters. Straight edges, that is 28 plus 28 is 56. We add to 44 and we shall have 100 centimeters.
Arc of a circle. Consider the figure below. The circle has a radius R with center O. The curve ABC is called an arc. The arc subtends an angle at O of theta degrees. The length of the arc is given by theta over 360 2 pi r. Example, if the radius of a circle is 5 centimeters and the angle at O is 60 degrees, the length of the arc will be 60 over 360 times 2 times 3.142 times 5, which gives us 5.24 centimeters. Area. The surface coverage of a plane figure is its area. The units of area are meters squared together with other units but squared. Common figures with their area. A square. All sides are equal two opposite sides are parallel, they are also perpendicular to the other two opposite lines. The area of a square is given by length times length, which is length squared. Rectangle. Two opposite sides are equal and parallel. They are also perpendicular to the other opposite sides. The area of a rectangle is calculated as length times width. Triangle is a three-sided figure. The area is calculated by a half times base times height. Has two parallel sides that are equal. Opposite angles are also equal. Area is given by base times height. Trapezium. For the trapezium below, side AB is parallel but not equal to CD. Area is obtained by half into bracket A plus B times height. Circle. A circle of radius r has an area of pi r squared. For a semicircle, the area is a half pi r squared. For a chord BOC forming an angle theta at O, area is theta over 360 times pi r squared. The shaded region in the figure is called a segment. Surface area. Surface area of a solid is the sum of the area of all its sides. Cuboid. All surfaces are rectangles and hence their areas are length times base, length times height, and base times height. Total surface area is 2 into LB plus HB plus HL. Cube. All surfaces are squares. There are 6 faces, hence the area is 6L squared. Cylinder. When a cylinder is opened up, as shown, it forms 2 circles and a rectangle. The length of the rectangle formed is equal to the circumference of the circle. Area of top circle is pi r squared, and so is the area of the bottom circle. Area of the curved surface, which is the rectangle now, is 2 pi r times h. Total area is pi r squared plus pi r squared plus 2 pi r h. This gives us 2 pi r into r plus h. Volume and capacity. The amount of space occupied by an object is its volume. Volume is measured in cubic units, that is centimeter cubed, meter cubed, and millimeter cubed, etc. Whereas area is the surface coverage in 2 dimensions, volume is the space occupied in 3 dimensions. Consider the cuboid below. The volume of a cuboid is calculated by length times width times height. In the case of a cube, the formula is the same, only that all sides are equal, hence it becomes length cubed. Volume is cross-section area times length. Consider the shaded part of the cuboid above. If you move along the width, the dimension L and H are constant as shown by the dotted lines. Similarly, the dimensions H and W will be constant along L. Finally, L and W will be constant along H. The area covered by a plane figure whose dimensions are unchanged throughout a certain length is called the cross-sectional area. Let's use a cylinder and a cone to extrapolate further. For the case of the cylinder, the bottom is a circle of radius r. Still at the level h, the radius of the circle remains r. The same radius is at the top. The cylindrical part is thus uniform throughout the entire height h. We therefore say that the cross-section of a cylinder is a circle. Now consider the cone. At the bottom is a circle of radius capital R. At the height h1, the radius reduces to a small r1 and further to r2 at height h2, such that capital R is greater than r1, which is greater than r2. The dimensions of the circle for the cylinder remain unchanged, while those of the cone are changing with height. A cone has no cross-sectional area. To calculate the volume of an object with a cross-sectional area, we simply have volume is equal to cross-sectional area times length. For the cylinder, area of a circle is pi r squared. If we multiply with height, we have volume is pi r squared h. Capacity. This is the amount of liquid that a container can hold. Capacity is measured in liters and its ratios, that is ml, cl, dl, and hl. The volume of a container determines its capacity. For simple conversions, a container with a volume of 1 meter cubed can hold 1,000 liters of liquid. Another with a volume of 100 centimeters cubed holds 1 liter of liquid. Hence, 1 meter cubed is equal to 1,000 liters, as 1,000 centimeter cubed is equal to 1 liter. These two relationships are very common and must be at your fingertips at all times. This table shows some conversions that are less common. For example, a metallic cylindrical tank with a diameter of 2 meters is filled with water up to a height 1.4 meters. If the tank has a height of 3.5 meters, calculate A. the fraction of the tank that is empty, B. the surface area in contact with water, C. total volume of the tank, and D. the amount of water in liters. In our solution, it is always good to sketch the figure as explained. The tank has a circular cross-sectional area, hence we can get the fraction by using its height. Empty height is 3.5 minus 1.4, which is 2.1. The fraction is 2.1 over 3.5, which is equal to 3 over 5. In B, since the water isn't full, it is not in contact with the top cylindrical lid, we shall only calculate the area of the bottom circle and the curved area up to a height of 1.4 meters. Hence, surface area is 2 pi rh plus pi r squared, which will give us 11.942 meters squared. Total volume is pi r squared capital H, which gives us 11 meter cubed. Volume occupied by water is pi r squared H, which gives us 4.4 meters. Using the conversion of 1 meter cubed equal to 1,000 liters, we have 4,400 liters. Example 2. A cylindrical tank A has a radius of 28 meters. It is occupied by 30,000 liters of water. If the water is emptied into a cuboid tank with length 3 meters and width 2 meters, how high will the water be? In our solution, first we convert 30,000 liters into meter cubed. This will be 30,000 divided by 1,000, which is 30 meter cubed. In the cuboid tank, water will occupy a volume of 30 meter cubed. Hence, 3 times 2 times h is 30, and h is 5 meters. Mass, weight, and density. Mass is the quantity of matter in a substance. Mass is measured in kilograms. Other dimensions are tons and grams. The table below shows simple conversions. The mass of an object is determined by comparison with a standard mass using a beam balance, as is common in shops and in butcheries. Mass is a scalar quantity. It is constant everywhere and has no direction. We will learn about this in later chapters. Weight. Every object near the surface of the earth experiences a pull towards the center of the earth. This is shown as free-falling objects. It means a force is acting on the object. A force is a push or a pull on an object. The result is acceleration or deceleration of the object. The units of force is newtons, abbreviated as capital N. Force is equal to mass times acceleration. The force acting on an object is called its weight. Through experiment, it has been shown that the mass of 1 kilogram has a weight of 9.8 newtons, hence the acceleration is 9.8 meters per second squared. This is the acceleration of a free-falling object. It is usually abbreviated as small g. Density. Density is mass per unit volume of a substance. Density is thus mass over volume. Units of density are grams per centimeter cubed or kilograms per meter cubed. For simple conversions, 1 gram per centimeter cubed is equivalent to 1,000 kilograms per meter cubed. When an object floats on a liquid, it is because the object is less dense than the liquid. From the formula, density is mass over volume. It is clear that when volume is large, the density is small. That is why a ship with large volume floats on water, while a nail with small volume will sink. Example: 2 kilograms of gravel with density 1.1 grams per centimeter cubed, 0.25 kilograms of cement with density 1.2 grams per centimeter cubed, and 3 kilograms of sand with density 0.8 grams per centimeter cubed are mixed. Find the combined density. We already know density is mass over volume. Therefore, volume is mass over density. Volume of gravel will be 2,000 grams over 1.1, giving us 18.2. Following the same for cement, we have 208.3 centimeter cubed. Same for sand, we have 375 centimeter cubed. The combined volume is 577.6.5 centimeter cubed. Combined mass is 4.05 kilograms. Density is 4050 grams over 5776.5, giving us 0.7 grams per centimeter cube.
You can go on and learn math. You may need tutorials, you may need tutors, etc., to get your foundation solid so that you can build the next course on it. But math is not so complicated that most people can't learn high school math and certainly the introductory courses in university. If you want to go on and major in math or do honors in math or do a career in math, you really do need to be good at it. But I think too many people stop out too soon because they've had bad experiences.